Today we will be talking about quadratic functions and models. We have already talked about linear functions, squaring functions. Let's talk about it again. So linear function is in the form of f of x is equal to ax plus b. You commonly know it as by mx plus b. Constant is just a constant on any number, and squaring function is x squared. That is the starting of the quadratic, right? Because when we add bx and c, then it becomes a quadratic function. So for linear function, the degree is 1. For constant, the degree is 0. And for the squaring function, the degree is 2. So this we can say that the polynomial functions are classified by degrees. Functions are classified by degrees. Right? If the degree is 1, then we say it as it is a linear. If the degree is 0, we say it as it's a constant. And when it is the degree is 2, we call it as a squaring function, or it is called a quadratic. Because for the quadratic function, we are looking for some properties of the quadratic function. And we know the quadratic function with the standard equation of ax squared plus bx plus c is equal to 0, provided a is not equal to 0, because if a becomes 0, then x squared is a 0 times x squared, it will be a 0, then it will become a linear function, right? So some properties of the quadratic function, when you graph it, it looks like a U-shaped curve, and there is a name for that, and the name is called a parabola. So parabola is the shape, is the name of the shape of the quadratic function, which is a U-shaped graph. Now in the real life application, we can think quadratic when we are talking about the reflective properties of satellite dishes and flashlight reflectors. So these are the common real life applications where you can see the quadratic function or the shape of the quadratic function. For every concept in mathematics, you need to understand the reason why and why it is used and where it is used in day-to-day life. Don't just memorize them for the sake of memorizing it and passing the test or just preparing for the test. Understand it in depth. So reflective properties of satellite dishes and flashlight reflector, these are some of the real-life applications. Then it is symmetric with respect to a line, that line is called axis of symmetry. With respect to a line called axis of symmetry, or AOS in a short form. You know how to calculate AOS. It is nothing but negative b over 2a, and that gives the x coordinate of the vertex. We will talk about it a little bit in detail as we move ahead. The another thing that we need to show is the vertex. So the vertex for the parent function, it will be a 0, 0. But the vertex will change as we transform the quadratic function. The curve will be upward facing when a is greater than 0, and the curve will be downward facing when a is less than 0, right? So a downward facing curve, that means we are looking for negative ax squared. And upward facing will show the y as the minimum value, and for the downward facing, it will show y as the maximum. The reason is when you are putting the graph as a U shape, so the vertex y coordinate of the vertex, that is the minimum point. After that, the y will only increase. So the quadratic function is ax squared plus bx plus c. This is how the graph will look like for the open upward, and open downward. So if you can see from the open upward, vertex is the lowest point. Because it is the lowest point, after that the y is increasing. That is why we get minimum y value. And when they're talking about the minimum or maximum, they are talking about the y values. They are not talking about the x values. The same thing goes with the downward facing graph. That is the highest y value it will reach. After that, the y keeps on dropping down. So remember, it is only the y value, it is not the x value that we are talking about. So that's why we say the leading coefficient should be positive. That means a is positive. Or when the leading coefficient is negative and a is less than 0, then it is a downward facing graph. So then we are talking about the transformation of the function. So the parent function is y is equal to x squared, or f of x is equal to x squared. And it has been transformed in two different ways. So parent function can be written for the transformation. It is a times x minus h squared plus k, where a is not equal to 0 and h and k, they define the vertex if it is written in this format. Now, let's understand this one. So we have a parent function y is equal to x squared, that is in the gray graph, and the transformated function, it is in the black graph. So the first one, because x squared is negative, the graph is downward facing. Plus 1 indicates that the graph is going up by 1 unit. So the black curve is the transformation function and the gray function is the parent function. For g of x, it says minus 3. That means we are going down 3 units. So in the first function, we are going up by 1 unit, and in the second one, we are going down 3 units. So this is how the transformation will work. Let's try one example, and let's try to rewrite the given function in the standard form. So we have the given function as f of x is equal to 2x squared plus 8x plus 7. So whenever we have to write any equation in the standard form, we always use completing the squares. You have learned with me the 5 different ways to solve the quadratic, and completing the square, we have done it extensively in the previous videos. So completing the squares, we talk about taking half of b, square it, and add to both sides, right hand side and the left hand side. And then we also use the property of a plus b squared. But in this case, instead of adding b, half of b squared to both sides, we will add and subtract it in the same parentheses, because we are just writing the function. We are not equating the function equal to 0. So let's rewrite this function, and we can factor out 2. So that will give us the parentheses x squared plus 4x plus 7. Now from x squared plus 4x, what is the b? B is 4, right? Using the completing the square, b is 4. So we have to do half of b and square it. So let's do it. So 4 over 2. No, it should be 4 over 2. I wrote it wrong. So because I took 8x, so don't make that mistake. We are not taking b in the original equation. We are taking the b after factoring it down. So it is 4 over 2 squared. And this one, you will get 2 squared, and that you will add in the parentheses with x squared plus 4x. Because the main purpose of completing the square is to rewrite the equation. We are not solving any equation, right? So I will do plus 4 and minus 4 in the same parentheses, plus 7. Now if you combine the like terms, not the like terms, the x squared plus 4x plus 4, that's what we need for a plus b whole squared. And minus 4 I can take out of the bracket, but when you take out the bracket, remember 2 is standing outside, so 2 will be multiplied with negative 4. So this will give you x squared plus 4x plus 4 can be written as x plus 2 whole squared, and it will be negative 8 plus 7, and just clean this up again. You will get this lovely equation in the standard form for the transformation purpose. So this is the transformation function, right? It shows 2 is outside. 2 outside implies what? Vertical stretch or shrink. Minus 1, what it implies? Going up or going down. So let's write down everything again. So we know from here the vertex is negative 2 and negative 1. But let's write down the vertical translation. So vertical translation is 1 unit down because it is minus 1. And then horizontal translation, because it is plus 2, that means it is going to the left, 2 units left. And finally, let's write down the vertex. The vertex will be -2, -1. All right, so the same concepts that we have discussed earlier about the transformation. So the only thing that you need to remember when you need to rewrite the equation into a standard form, always use completing the squares. Now, the another thing that we need to discuss in this chapter is called finding the minimum and maximum value. Remember, as I told you, minimum and maximum value, we are talking about in terms of y. We are not talking about in terms of x. This is the common misconception. Students, they tend to write the value of x as the minimum or maximum. Always write for y. And this will continue even for higher grades as well. So the basic function is ax squared plus bx plus c is equal to 0, provided a is not equal to 0. And I have told you previously in this unit only that axis of symmetry is also called AOS, and we can calculate by negative b over 2a. Now this axis of symmetry will give you the x value of the vertex. And once I know the x value of the vertex, can I figure out what is the y value of the vertex or the maximum or minimum? Yes, you just have to plug the value of x in the given equation, which is ax squared plus bx plus c is equal to 0. And you will get the y value. Also, we have talked about how to, just by looking at the equation, how to understand whether it will give you a minimum value or the maximum value. So the rule is something like this. Let me rewrite it again. So when a is greater than 0, now a is the leading coefficient, right? Then we are expecting minimum value of y. When the leading coefficient or a is less than 0, then we are expecting the maximum value of y. So just by looking at the equation without solving it, you can understand or you can estimate whether it will generate a maximum or minimum. Let's try to do this practical example. This example is related to finding the maximum height of a baseball. So always highlight the key important points that are given in the word problem. It will help you to solve the problem. So we have a function f of x is given, and they also said that the f of x is the height of the baseball, and they want us to calculate maximum height of the baseball in feet. So let's start by writing maximum height of the baseball, and let's write the f of x function. Now copy the function down very carefully. Often students, they make mistake in copying the equation down incorrect, and then the whole entire answer is wrong because the equation was wrong. Now if you look closely at the equation, the leading coefficient a is negative in this case. So what we can predict? We can predict that there will be a maximum value of y, and that's what the question is asking for, right? So we are on the right track. So let's find out first AOS, negative b over 2a. Now b is 1 because the leading coefficient of x is 1. And a is negative 0.0032. So use your lovely calculator. And when you plug it in your calculator, you should get 156.25 feet. Now this is the x value of the vertex. We want the y value of the vertex. So what we will do, we will plug this x value in the original equation, which is f of x. So let's plug it. So we have f of x is equal to, which is nothing but the y value, squared plus 156.25 plus 3. If you plug everything in the calculator, you should get 81.125 feet. So that is the maximum value of the baseball for this particular question. So do write the word sentence in the last. So maximum height of the baseball is 81.25 feet. You can also graph this on Desmos and see how the graph looks like. So the graph will be facing down. And it makes sense. When someone is hitting the ball will go up and then come down. So it will create a parabola. I hope this lesson made sense to you, and I will see you in the next video.